Hello everyone, this is Kevin Zhao, your finance professor at MTSU. In this video, I'm going to show you the process I solved question 5 in chapter 14, which is about free cash flow to the firm valuation model. Let's read the question. And once again, when you solve a problem, I really like you to reinstate the problem in this Excel spreadsheet so you can check your work in the future with a greater convenience. Biomed Inc., a company, reported earnings per share 56 cents in 1993. It had to pay no dividends. The revenue per share in 1993 was $2.91. It had a capital expenditure 13 cents per share. In that year, depreciation 80 cents per share. Working capital was 60% of revenue in 1993. Was expected to remain at that level for the next 5 years, when earnings revenue were expected to grow 17% a year. Earnings growth rate was expected to decline linearly to 5% in year 2003. So there's another stage between 1999 to year 2003. The growth rate will decline from 17% to 5% linearly. That will be the second stage. Working capital was expected to decline from 60% of revenue to 30% of revenue after year 2003. So after year 2003, there will be a steady growth rate or low growth time period, which is a sort of terminal time period. The firm had no debt currently, but a plan to finance 10% of its net capital when the end working capital reinvestment with a debt. The stock was expected to have beta of 1.5, 1.45 for the high growth period between 1994 to 1998, and it declined to 1.1 by the time the firm goes into steady state in the year 2003. Treasury bond rate is 7%, ERP is 5.5%. So we need to estimate the stock price. In this case, there are 3 questions, A, B, C, and let's solve for A. And B and C would be easy because we simply change the assumption in our Excel spreadsheet to get the answers. So let's take a look at question A, estimate the value per share using free cash flow to equity model. And when you read this question, it looks pretty complicated because you will have 3 stages. First one is high growth time period from 1994 to 1998, 5-year high growth time period with a growth rate of 17%. And then you have a second stage, 1999 to year 2003, during which the growth rate will decline linearly from 17% to 5%. And the last stage is the terminal stage, where a company will have low growth rate of 5%. You have 3 stages. And actually, in this case, I do 4 stages. I will tell you why. And actually, the year 2003 was set as beginning point of the constant growth rate, but here I treat it as a very unique time period here. Let me use another color. I would say this is a very tricky transition year for year 2003. But anyway, it looks like 3 stage, but actually it's a 4-stage problem. So in year 1993, EPS 56 cents, capital expenditure, depreciation, everything is in per share basis, and working capital 60%. Let's look at the 60% of the revenue, $2.91 per share. To get a working capital. Then let's do estimation for the high growth time period. EPS will grow at 17%. The same for capital expenditure, depreciation, amortization, and what about the revenue? Revenue, yeah, the revenue is the same, 17% growth rate. And then you can estimate all those numbers in those yellow cells. And working capital will be 60% of the revenue, and the difference, year-to-year difference in working capital would be the change in working capital that is part of your investment. And also we have change in debt, That is 10% of the net capital expenditure. Let me see if it's net capital expenditures. 10%. Okay, the company says that, okay, but plan to finance 10% of the net capital and working capital investment with debt. Net means capex minus depreciation, amortization plus working capital investment, changing working capital, then times 10%. So it's 10% times capital expenditure minus depreciation, amortization plus change in working capital. That will give you change in debt. Copy this all the way down to the end. And then you can calculate free cash flow to equity, which equal to capex, EPS minus capex, plus depreciation amortization minus change in working capital, and plus change in debt, This equation will be the same all the way down to the end. Let me double check. EPS plus depreciation minus capex. Okay, that's right. That is the change, the net capital expenditure. Then minus change in working capital, and a plus change in debt. Okay, that is correct. And then the cost of equity. Okay, cost of equity. Before we do present value of free cash flow to equity, you needed to develop a side table here. Because beta are different between two time periods, 1.45 during the high growth time period, and low beta after year 2003. So betas are different. Therefore, this cost of equity would be different between those two time periods. And given 7% T-bond rate and ERP 5.5%, I got about 15% cost of equity during the high growth time period, and the 13.05 cost of equity during the low growth time period or constant growth time period. And during the second stage, the growth rate will decline linearly from 17% to 5%. So here I do approximation of linearly declining growth rate estimation. Let's say 15% for 1999, 12% year 2000, 10% year 2001, and 7% year 2002, and 5% in year 2003. And then I estimate EPS, capex, depreciation, amortization, as well as the revenue. But here, the working capital channel will still be 60% of the revenue. And then I calculate change in working capital, so on and so forth. Right? But in year 2003, the change of working capital declined to 30% of revenue. You see? Previously, working capital was 60% of revenue. In year 2003, revenue continued to increase, right? Your investment in working capital didn't increase because the percentage declined from 60% to 30%. And here is a odd number. So when you calculate change in working capital, you get a negative number. Be careful about that. Because this number means release of working capital into your free cash flow to equity. So previously is in year 2002, that is $1.37, but in year 2003 it jumped to $4.28. Right. So many people stop their table in year 2003 because they assume year 2003 would be the beginning year of the constant growth time period. And if that is the case, the mistake would be to overestimate the value of the terminal value. and I'll show you why. Because in year 2004, this change in working capital will decline to 15 cents. And if you ignore this negative number here, then you would assume that increasing free cash flow to equity would be sustainable, will continue into future year, which is not realistic because in year 2004, free cash flow to equity will decline to a normal level. Previously $4.28, then in year 2004, $1.75. The reason why you have larger amount of free cash flow to equity is not because you're getting better operating results, but because there's a large amount of release working capital. But this release of working capital is a one-time thing, and it cannot happen every year. That's why I needed to make this year 2003 a very unique time period. And I would treat this year 2004 as a true beginning year of the constant growth time period in order to calculate that terminal value. So this is a typical four-stage model. You have high growth time period 1994 to 1998, then linearly declining growth rate for the next 4 years, and reach the steady state in year 2003. But year 2003 is very special because large amount of release on working capital, which caused the jump in this FCFE. But this large number of FCFE is not sustainable in the constant growth time period. Therefore, I treat the year 2004 as the beginning year of constant growth time period. So once I have everything ready here, okay, working capital, changing working capital, and FCFE, of course, my goal in problem solving is to get the right number for FCFE. And then I discount this FCFE by using different discount rate. High growth discount rate was about 15%, and the low growth time period beta would be low, therefore cost of equity would be low, 13%. So I use different discount rate. And between first stage and the constant growth time period, assuming the cost of equity would be average of those two numbers because it's transition time period, that would be a realistic assumption. I would state my assumption, adding a comment here. Every time, I mean, you can add assumption, but make sure you add assumption in the comment box, assuming lower cost of equity during the linearly declining stage. Okay, so this is your assumption. It's not in the question, but it's more reasonable to impose assumption in this table. Right? And make this number as a special number. And the comments would be that the large release of working capital only happened once in this case, which is not sustainable. That's why I make year 2004 as beginning year of the constant growth time period. So year 2004 is the beginning year of constant growth time period, although the growth rate is same as year 2003. Right. So once I got this free cash flow to equity right, as well as cost of equity number right, then I can do calculation of present value. Present value is discounted free cash flow to the firm, to the equity, right? And with the power of number of years. and so on and so forth. So I get 10 years of free cash flow to equity as well as present value, and then I calculate terminal value using year 2004 as the beginning year. And if FCFE is $1.75, then divide by the difference between cost of equity and the growth rate, and then divide by, and then discount for 10 years. Notice that discount rates are different. Therefore, the first discount rate is 13%, second discount rate 14% for 4 years, and 15% for 5 years. See that? 13% for 1 year, 14% for 4 years, and this 15% for 5 years. That will give me this terminal value. When I add up terminal value and the present value for all previous 10 years, present value of 10 years free cash flow to equity, I get this stock price estimation. So that is question 5 in chapter 14. Question 5 in chapter 14. I think you will come across a similar problem in your second exam where you have to treat this year very carefully. When company have large release of working capital, you shouldn't make this as the beginning year of the constant growth time period. And you treat it as special year and take the next year as the beginning year of the constant growth time period. Otherwise, you will overestimate the terminal value. You will get it very wrong. Any questions, let me know, and I hope you enjoyed this video, and I will show you other videos on how to solve some difficult problems in different chapters. Thank you so very much.